address is the most common programming format used for CNC programming systems. This format contains a large number of different codes that transfers program information from the part print to machine servos, relays, microswitches, and many more, ultimately to manufacture the part. These codes are in a logical sequence called block of information. Each block should contain enough information to perform one machining operation. Every program in any part to be machined must be put in a format that the MCU or machine control unit can understand. The format used on any CNC is built in by the machine tool builder and is based on the type of control unit on the machine. A variable block format which uses letters is most commonly used. Numerical data follows this address to identify a specific function such as distance, feed rate, or speed value. The address code G90 in a program tells the control that all measurements are in the absolute mode. The code G91 tells the control that measurements are in the incremental mode. The most common codes used for programming CNC machine tools are G codes and M codes. G codes are for preparatory functions and M codes are for miscellaneous functions. Other codes such as F, S, D, and T are used for machine functions such as feed, speed, cutter diameter offset, and tool number. G codes are sometimes called cycle codes because they refer to some action occurring on the XYZ axis of a machine tool. The G codes are grouped into categories such as Group 1, Group 3, and Group 9. Group 1 contains codes G00, G01, G02, and G03, which causes some movement of machine table or head. Group 3 includes either absolute or incremental programming, while Group 9 deals with canned cycles. A G00 code rapidly positions the cutting tool while it is above the workpiece from one point to another point on a job. This is what we call, in terms of CNC machines, rapid traverse movement. The G01, G02, and G03 codes moves the axis at a controlled feed rate. G01 is used for straight line movement or linear interpolation. G02 and G03 are used for arc and circular interpolation. G02 is for clockwise interpolation and G03 is for counterclockwise circular interpolation. Some of the most common G codes in CNC programming are listed here. Now, M or miscellaneous codes are used for either turning on or off different functions which control certain machine tool operations. M codes are not grouped in categories, although several codes may control same type of operations, such as M03, M04, and M05 controls the machine tool spindle. M03 turns the spindle clockwise. M04 turns spindle counterclockwise, and M05 turns the spindle on or off. In the next lecture, we are going to write a simple program which will involve all these codes that you have learned and best practices used in CNC programming. Before we write any program, we need to look into the coordinate system. The most common kind is the Cartesian coordinate system. You are probably quite familiar with this system because this is what you have used while plotting graphs in school. Let's go over how this coordinate system translates to CNC machines. This here is an example of a typical CNC milling machine. As you can see by the axis on the diagram, the table moves along the X and Y axis while the Z axis dictates the up and down movement of the spindle, which also controls the depth of cut. On a standard CNC lathe, these axes are slightly different. The Z axis runs along the center line of the lathe, whereas the X axis runs at a right angle from the center line of the component. Let's get back to the graph and see how it works when we are writing a program. The circular symbol in the center of the graph is what represents the datum position or the origin. This is the point where the coordinates of x and y is 0. Any dimension above or right of the datum would be positive, and any dimension below or left of the datum would be negative. So our first point on graph would be 1, 1 when both x and y is positive or positive 1. The next coordinate here, as you can see, is 2, -3, which means x is positive 2 and y is negative 2. And hence it's below the datum position. Now as we move into the bottom left quadrant, you can see now the x and y values are both negative, and finally we have negative x and positive y in this quadrant. So overall, the top right quadrant or the first quadrant will always have positive and positive values. Bottom right or second quadrant will have positive x and negative y values. The bottom left or third quadrant will have both negative, and the top left or fourth quadrant will have negative x and positive y value.